Okay, so thank you everyone for joining this meeting. So this is going to be a very light introduction to Docker and how you can use it in your work, in your development. So I put all the code that I'm going to show you. I put it in the Matrix Lab GitHub. There is this repo Docker introduction. Yeah, so all the comments that I'm using, they're going to be there. If I miss anything, I'm going to put it after the meeting. Yeah. So, yeah, ask me question after if you have any question. So a quick disclaimer. So I'm not at all an expert in Docker. I've used it a few times in my life, so I know how to manage, but this is really just an introduction. We can maybe later during the year do a second part if people are more interested in more complex usage. And this presentation is focused on how to use Docker in a deep learning context, but you can use Docker for a lot of things, for a lot of different software development. But here we're going to focus on deep learning because this is what I'm familiar with. Okay, so a lot of things to uncover. So what is Docker, how to use it, when to use it. Basically, there are three main concepts that you should be familiar with. So I'm going to detail that, and then how to start. And yeah, at the end, we're going to do a practical example. I'm going to try to show you how I can run Dockers. Hopefully it's going to work. So, okay, let's start. So what is Docker? A very, very simple definition of Docker. That my favorite one is Docker is a way to package software so it can run on any hardware. That's as simple as that. You have a piece of software and you want to run it on a machine, on it can be your software can be some Python code, or code, Java code, whatever. It could be a software like a new MSM. It could be an iOS app if you're developing an app, database infrastructure. It could be anything. And your hardware can be also almost anything. It could be a laptop, a Raspberry Pi if you're doing some very fancy development on machines, on robots or whatever. You can do some desktop machine, a cloud server. It can be anything. And the idea is to be able to reproduce your software on any of those hardware easily. So my opinion on Docker is that, to be honest, today is an essential piece of the deep learning developer toolkit. I would put it at the same level as Conda or Bash, because a lot of different repositories are actually using Docker and can simplify your life a lot. The only thing is that there is a bit of a learning curve, but it's not that complicated. Just need to understand the concepts. And the good thing is that there is a huge community. There's plenty of videos on YouTube. You have blogs. You have a lot of things that can help you start with using Docker. So yeah, for the people that don't know at all what is Docker, it's this. Maybe you have seen this little logo. This is the Docker. So why using Docker? So I'm going to focus on two main reasons of why using Docker. The first one being creating a flexible working environment. So I guess it happened to you a lot, but it happened to me a lot during my PhD, past few years, since I started my PhD. I not always working on my machine on BioEnv 444. Sometimes I have to work on other machines. I have to work on 354. I need to move my code around, and it can be very painful. So the idea is to use Docker to create something that you can move your code easily and you can run it easily across different machines. So let's start with something super simple. So any hardware you're using, so this is the building block of your machine. You have a laptop, you have a desktop, a server, whatever. On top of this hardware, you usually have an OS. So it could be a Linux, it could be Mac OS, it can be Windows. So everything I'm going to show you actually is for Linux. It can be translated very easily to Mac OS. For Windows, I have never tried, so I can't tell you about that. But, so usually you have your hardware, you have an OS on top of it. Sometimes you have on your machine, you have a virtual environment. Most of you, I guess, are using Conda. It could be VM as well. And then you on this virtual environments, you install libraries, PyTorch, and by whatever. So a little something I'm going to add, but if it's not, it's important, but it's fine. We can pass it. Is that between your OS and your virtual environment, if you have a GPU machine, sometimes you have what's called CUDA drivers. So that enable your GPU to work properly. So we're going to pass on that for now, but keep that in mind. So, okay, so I have my machine. So by range 444, I have Ubuntu on the machine. I have a conda and I have a library. So this is me. And most of the time, what's going to happen is that I need more GPUs. Like it always, I want more GPUs. I want to like new to run more code. So what I'm going to do usually is that I'm going to go on the Slack channel GPU server and I'm going to ask, can I use one of the GPU on 354? So most of the time, Emma is going to say yes, of course, you can use one. And then I'm happy. I'm going to say, okay, cool. I'm going to go on 354. So first thing I'm doing is that I'm copying my code on 354. And then I'm a bit confused because I'm not sure what is the Linux there. And is there an Anaconda on the machine? I have no idea. Is there like PyTorch or like, is there like any library that I'm using installed? Well, usually you're not sure. Okay, so well, I look into the Linux installation. It's like 18, so well, fine. It's not that old. Then I start looking into the CUDA because I know that I need PyTorch, and usually you need to install the PyTorch that is corresponding to the same like CUDA that you have installed. And on my machine, I have 11.8, and on the BioH354, there is 11.6. So already I'm like, well, if I'm lucky, it's going to work. If not, it's not going to work. And then I realized that, okay, I need to install everything that I have on my own machine, and I have to install it here. And yeah, I'm like, no, I really don't want to do it. And so I started Googling like everything, like for like the 1 millionth time, I need to install OpenCV, I need to install PyTorch, I need to install that. It's very painful. And 3 hours later, okay, I can do it. It's fine. Like it works, but it takes a lot of time. Okay. So this is why Docker can be useful. Like Docker, it's a thing that is going to be between your hardware, like the thing that usually you don't, it's IT that deals with that, and the thing that you interact with. And it's in between. So yeah, so basically Docker is going to manage what we call an application, which is the code, the libraries, the environment, everything. So, and Docker is gonna, so it's gonna encapsulate all that and trying to easily put it on a new machine. Okay, so the first point, I hope it was kind of this, like to create this kind of flexible environment. A second point that I won't go too much in details, but I just wanted to mention, is that you can use Docker for versioning. Why? Because once you have a Docker that works, basically you have a static block with your code, your libraries, everything in it, and it's frozen in time. Like it's not going to change. You can use it in like 5 years if you have the good CUDA and you have like a machine that still works. It's going to run on it. So what I'm trying to do, but of course it's very difficult, is that every time I have a piece of code that I think is like it's working, I just create a Docker for it. And this is going to be my version 1. And then I have a version 2 and I have a version 3, and I can use them even like a few months later. If I completely forgot how to run my code, I can just use my Docker. And I know that it's going to work because all the libraries that I need to run my code are there. But yeah, we can discuss that later, but I don't have like a clear example. But basically for versioning, you have like, you can use Docker alongside GitHub and you can create packages with that. Okay, so when using Docker, of course, like anytime, especially I would recommend it when you need to use temporarily on the machine and you don't want to mess everything on the machine, like by installing stuff that you're not sure. And especially also when you're using servers. So I'm using it for Run AI. I mean, we have to use it actually, but it's a way to use it. Create, I don't know, but I guess you can use Docker and Create. I've never tried, but that could be also a way. So okay, you might be wondering why not using just Conda. Like in Conda, it's easy to use. So yes, true, they both like they can, like Conda and Docker can both manage environments, but the problem is that Conda works at the package level, as Docker works at the application level. So Conda, you're just dealing with libraries. You're just trying to install the libraries with the correct like versions. On Docker, you have your libraries, but you also have your data. You can have some data. You can have your code. Everything can be encapsulated into that. Okay. Any questions for now? It's kind of clear. Okay. Okay. So there are really 3 just three little pieces of vocabulary that you need to be familiar with before I go further. So it's a Docker file, actually it's Docker image, sorry, Docker image and Docker container. So I'm going to try to explain quickly what are those three things. So a Docker file is like the basic concept of Docker. It's just a simple file that contains the instruction you need to build your Docker image. So for instance, I need PyTorch with that version. I need this code. I need this data. I need this workspace. Okay, I'm going to show you the examples later. Then an image. So given your Docker file that you just created, you can create an image, which is like a static snapshot that contains the application, the code, the libraries, the dependencies. It's like a part of, like, it's just a block. I mean, I'm going to show you, but it's just a package. You can imagine like a package with everything inside. And then a container is just an instance of that image. So it's just a runnable instance, providing the environment that you are interested in executing. And you can have, for a given image, you can have like multiple containers. So imagine that I have, like my transformers, I want to run them at the same time on the DHCP dataset and on the HCP dataset. So I can have the same image for my transformer repo, because the code won't change. It's the same code. It's the same libraries. In any case, for HTTP or DHCP, it's going to use the same. The only difference is going to use different data. So I can create a container for the DHCP data and a container for the HTTP and run both of them in parallel. So yeah, so just a little illustration. So it's not great resolution, but this is really the only concept you need to know. You need to know that we have a Docker file, we create an image, and then we create a container out of this image. Okay, so let's start doing some code. So how to start with Docker? Very quickly, there are three ways. Of course, you can use like a terminal, you install Docker. I put the link here in the GitHub, and then just check that it's running. It should be fine. I recommend, if you have a Linux or Mac OS machine, to use Docker Desktop. It's like at least you have like, you're not doing everything in the terminal, but you have like some sort of like software you can interact with, so you can access your images, the containers. You can do some search here. I'm going to explain why later. It's working on every platform. And last thing is that if you're using VS Code, which I recommend, there is also an extension of Docker on VS Code. This is very, very, very useful. Okay, so let's start with the first piece, which is a Docker file. So here I'm going to take an example of my code. I'm going to show you how to write everything, and then we're going to try to do it on my machine and see if it works. So how to write a Docker file? It's very simple. It's just a few instructions that you need to run your code, your piece of code, or software. So the first part is the from. So it basically tells you, so there is, so alongside Docker, there is this Docker Hub, which is a huge database with a lot of images that people have developed over the years, and that you can use directly without having to care about installing very complex libraries. So for instance, today it's kind of easy to install PyTorch, but at some point it was super complicated. Also, TensorFlow might be a bit tricky. So you have those images that are available, and you can just refer to them with this from. I'm going to show you how you get to this path, and then it's going to download for me the 2.1 version of PyTorch with my CUDA, which is 11.8. So that's the first thing. So Docker Hub is just another website, or you can access it directly from the Docker desktop application I showed you before. You look for what you're interested in, so PyTorch, for instance. This is the latest version, so you can just pull the latest version. But if you want something that is a bit more precise than that, there is the tags here, and you can look for the exact version that you want. So for instance, here it's 11.6, here you have 11.3. So you can look for exactly the one you want. You copy that little link and you use it in the Docker file. An example, I don't know if people are using Monai. I'm not, but I'm not that a lot of people are using Monai. Monai also have an image. So if you don't want to reinstall Monai every time, you can just use the Docker Monai image, and it's gonna be easy for you. So that's the first thing. Then once when I have like in my Docker image, I want PyTorch, but I have also other libraries. The other libraries, I put them in the requirements.txt file, just like matplotlib, numpy, pandas, whatever. So I just need this copy command is just to copy the content of that, and then with the run command, you just pip install everything inside. Okay. Then you don't need necessarily to do everything, but you might want to install some extra piece of commands, for instance. So I don't know, I use a lot of htop to monitor the CPU usage. You can, if you are sudo, you can install Git if you need to install Git. You can use, so you can run any of these basic commands here to install them inside your Docker. And okay, and then you just refer to where you want your working directory to be. So that's really like you can easily just reuse this Docker file that I put on the GitHub. You can reuse it and like tweak it for your particular application, and it should be working. Okay. So any question on that Docker file part? Yeah.
But like the tags, they're just different images, right?
Exactly. There are different images. Yeah, and you can import if you need multiple like libraries that like if you need Monai plus PyTorch, you can like I'm sure that in Monai you already have PyTorch, but you could have both. You could install both. You do a from and then you have another from. So like here you can see like sometimes I need to change because for instance if I am on the 3.5.4, I need the 11.6 version of PyTorch. Right? Like here's like CUDA, but it's fine. Like you could just tweak it so that it works on your particular hardware. Okay, so that was the first thing. That was the Docker file. Second thing is the Docker image. So once you have a Docker file, now you want to build your Docker image. So there is a command docker build, which is made for that. So I'm going to show you a few. So yeah, this is an example of how you can like a few tags that you can use. It's not very important, but so no cache is just to install everything, but you don't need to think about that. This is just here the path to your Docker file, and this is just the tag that you want to how you want to name your image. So I want to name my image SIT Python 3.8. That's it. So once this is done, so you take like what happens is that when you run this command, you have like everything that is installed. Like it takes like 80 seconds. It installs PyTorch, everything that you need that you specified in the Docker file, and then you go to. If you check these Docker images, you can see now that you have the repository. So this is the one I've just installed. You have the tag, and yeah.
Can I go back a few slides?
Of course.
When you were saying the example with your frogs, then
Yeah.
you're saying if you were on 3.5.4, you needed to install CUDA 11.6. Does that mean you have to know what? Like, I thought the whole point was that you kind of abstracted away from what the underlying.
So I think in practice, yes, you don't need to specify. The only thing is that it happened to me, but not related to Docker, it's related to PyTorch, that sometimes if I install the 11.8 on an 11.6 machine, PyTorch fails for some reason. It's not related to Docker. So like I can go on 3.5.4 and just use the exact same, and it should work. But if you want to make sure that you have a perfect like compatibility between your code and the PyTorch version, I would recommend specify.
So you do need to know what the CUDA version is.
Yes, at least that. Yeah.
And the CUDA
Yeah, but no, that's not this way. I mean, because on Docker you will have just the one that are like compatible.
Okay.
So you shouldn't. The only thing you should care about is like, I haven't tried like for this example here. I haven't tried if installing this one at 3.5.4 will work, despite the fact that it's 11.6. But it should. It's just I prefer to like it's just a line to change. So I prefer to change it. Yeah. So where are we? Okay, so we have installed, we have Docker build, so we have installed our image. You can find it here. Okay, now let's move to the containers. So now that we have our image, we can build a container. that's going to run our code. So again, there is a very simple command, which is docker run. This one is a bit more interesting because you can play a bit with it. I'm going to show you a few examples. If you have questions, let me know. Let me pass that. So the docker run. So don't be afraid. It's like just put an example of how I'm using it. It's maybe a bit too much, but it's nothing. Like I'm going to break it down. So the first tag is iterative. If you want to run it iteratively, so if you want to interact with your Docker container, so if you want to have a bash that opens and you can type things inside, if you don't put this tag, it will just run your command that you specify. So if your command is Python train blah blah blah, it will just run the command. I prefer usually to use the interactive version and go inside. So then you can specify which GPUs you want to use. So here, all. And then there are those .v's for volumes. It's a few tags where you can specify like your code, your data, everything. So here, if you remember in the Docker file, I was showing you before. It's here. There is this copy thing. So you could, for instance, copy your entire repository inside the Docker. Like all your code, you can copy it inside with the copy, and then you just put the path of your code. I preferably, like, so when I'm just developing, I don't like doing that. I prefer just referring to the volumes on my machine. So I'm just creating a link that's gonna, for my Docker container, to know where my data is, for instance, or where my surface vision transformer code is. And you do that with just this tag volume. So here I'm just gonna say where is my data, where is my code, so that it knows. It's not going to be copied for like forever inside, but it's just like going to be like just a link for like as long as my container is used. Then you have your working directory. It's not very important, but then you have this tag which is quite useful. Is to say how much memory you want your Docker container to use. Imagine that you have we are all using the BioEng 354. There is like a limited amount of memory. And I don't know, I run my code and I forgot to remove the tag in my deep learning that's going to save my checkpoints every epoch. And I started the thing for 10,000 epochs. And then the day after, no one can like open the BioEng 354 because there is no memory left. There is a way to prevent it, because if you do that, you know that your Docker is going to, like, you're going to associate with your Docker container just 10 gigabytes here. And that's the maximum. If it goes above that, your Docker container is going to be killed. And then you just have you just specify which image you want. So it's forget about the 5 here. It should be just SIT Python 3 container that we just created. Once you do that, you can see you can run Docker container, and you can see that I have my Docker container that was created. Okay. So a few more things that you can about the tags. They are very useful. It's very flexible. So here you remember I put GPUs all. Actually, I can just use one GPU. So if I do that, for instance, GPU device 0, my Docker is going to be aware of just one GPU on the machine, and that's it. If you run nvidia.-smi to check the GPUs, inside your Docker container, it's just going to see one GPU, the one that you specified. And it can be very useful if a lot of people are working on the same machine. We can all decide on who is using a GPU, and we can just use the different containers on different GPUs. And we're going to be sure that no one is going to crash someone else run by using loading too much memory on the GPU or whatever. So yeah, so you can specify that like this. Another thing that, I mean, it's a bit too much, but you can also specify the number of CPUs. Imagine you have like a huge machine, but you want to just allocate 30 or like 2 CPUs to your Docker container. You can do that, and you can even specify which cores you want to use. So again, that can be useful depending on the application. Okay, so now we can try to little example. We can check on my machine how to do that. So yeah, the practical example we're going to do is that I have some code, as I was explaining, on BioEng 404, but I need to run it on 354. So yeah, let's see how we can do that. Give me a second. seconds. Okay. Do you have any questions before I go into an example? Can you see? Oh, is it too small? Okay. Okay, so this is like just my working environment. So I have the code we're interested in is this one, like the surface event transformer. So first, so this is just my machine. So if I try to start my code, it should look like. Let me just. So let's start a training. So it should start normally and using some of my GPUs. So training start, like we have the first epoch, and we see the GPUs here, this one. Okay, so let's kill this one. So it works on my machine. Now let's try to do everything that we did with Docker. Let's try to replicate and see if it works with Docker. So if I check the Docker images that I have already, so we're gonna try to install to Docker build the image that I was talking about before. So I'm just checking out here. Okay, good. What's happening? Oh, sorry. Okay, so this is the first thing. It's going to build my Docker. So if I show you, again, you have this code on the GitHub. So my Docker file is the one I've just showed you before. Like the from Python, the copy, and everything inside. So it's going to take like a few seconds to install everything. Should take like 80 seconds. How do you install MSL, the new MSL?
Mostly from source.
From source.
The MSL guys provided the developer package. Yeah, I use like it's called that.
Okay. Do you think it would be useful to use Docker for that?
Certainly, but I think at this point it's the versions are changing.
Okay, yeah, so there is no point. Okay, so now, okay, so we installed the Docker. If I do Docker images, now we see it. Okay, perfect. So now let's try to build a container based on that image. So this is just the command I showed you before. If I start this command, now I'm inside the container. So if you look inside, you can see that the only thing that you see is the surface viewing transformer because this is the only part of all my workspace that I've copied inside. So this is the only thing that you're going to see inside. If I look at the GPUs, so we have access to all GPUs because I've specified GPUs all. And if now I go inside tools, sorry, and I do the same command that I was doing before, so the exact same command, this should work similarly. Okay. This is hopefully there is no bug. It's going to work. Just wait a couple of seconds to see if the first epoch runs. But it should be fine. Yeah. So it works. Okay.
Are you running this on 3.4 now?
No, I'm running still on my machine. I'm just it's just on my machine. It's just I created a Docker container doing the same thing that I was doing before on my machine, but inside Docker. So you can exit it. So here you see that here I'm on my machine. And when I did this command here, I started a container. Well, it's not very clear, but it's not the same thing like that. It's inside the container that is on my machine. So just something I wanted to show you. If I just go here and replace device for 0. So now if you look at the GPUs, we just have one GPU. The Docker container is just aware of one GPU on your machine. That's it. Okay, so that's the first part of the job. So you need to create the Docker file, make sure that it works on your laptop as it should be working. And then let's try to see how it's going to work on 354. So let me just. Sorry. Okay, so this is now, so this is just another VS Code window, but it's SSHing on 354. So now this is my code on 354, my repository. So the only thing I did before the meeting was to copy the code that I need, because that's the only thing I need to transfer from my machine to the other, because that's what I want to run. Okay, so now so there is Docker on the 354, fine. Let me remove just this Docker ID. Oops. So, okay, so now there is no Docker images anymore on the machine. I'm just gonna build it similarly as I was doing on my machine. So just taking a few seconds. So here you can see the CUDA version is different. Like it's 11.6. So I think I changed it, but it might not be a requirement. Yeah, so here I've changed it to 11.6, but it might work as well with 11.8. But yeah, that's maybe the only thing that you should check if there is a problem. So yeah, again, these Docker images, like we're doing it here, but you have to do it once. Once your code is working, you do it once, you have a Docker image, and that's it. You just like run your code as you would do. Yeah, that's right.
Package CUDA, CUDA with the Docker.
The CUDA?
The CUDA into the Docker.
That I don't know. I think so,
Because
but
I understand that you can do it with the driver.
yes.
That's our Docker, but
actually, you might.
because it's a library. If you
Yes, you're right. I mean, I saw this illustration before, and I find it quite like it makes sense. So probably, yeah, you can probably put the CUDA toolkit inside. But yeah, I mean, I've never done it. But usually I don't want to play with the drivers or whatever.
it's all about drivers, so yeah, don't play with the drivers.
Yeah.
That's a mess. But I think the CUDA toolkit is over that.
Okay.
So at least it doesn't try.
Yeah, definitely. So so you can see here now we have the Docker image that I'm interested in. I'm in the base Conda environment, so I'm not even interested in like installing Conda environments or whatever. Then I just need to run my image. Okay, so again we are inside the container now. Again, there is just the code, and hopefully it's going to work as well. Okay. and hopefully it's going to start. So like, despite the fact that I didn't show you how I put the code from one machine to the other, which is nothing, like it took us like less than 2 minutes to start a code from my machine to another machine with the CUDA dependency and everything. And it works. Like, there is nothing else to do. So yeah. So basically, I think that's what I wanted to show you today. Let me just check. I think I have a couple of more remarks. So yeah. So in a lab environment, it can be useful because it's to like enable like reproducibility. Like imagine tomorrow I need to run my code on my Dahan's machine. I can do that like very easily without having to worry about anything else. I think it's good for open science because if you put your Docker image on your GitHub, people can just download it and use your code very easily. They don't even have to install everything, which usually might take some time to do when it's not like very well documented. And for test and debug, it can be also useful to have some versionings and like some versions of your thing. So there are way more sophisticated commands on Docker. You can. This one is very popular. Compose is to do a lot of different builds and runs together, but I'm not gonna. I don't have time. I don't have the expertise. And yeah. So basically, I think that's what I want.
Yeah, super good.
Have any questions?